The method of surveying railway lines in the UK is defined by Network Rail. They stipulate the accuracy together with the methodology for correcting errors in those surveys. LSS has two commands: Report Rail Overlap and Report Rail Gauge. These commands will also be of value to surveyors outside of the UK because the options built into them allow different parameters to be entered in order that they comply with that country's specification. For surveyors using EDM, GPS or a combination of TMDs or track measuring devices, there is usually a maximum permissible distance that any single survey point may be observed from any station setup. Therefore, repeat measurements from the next survey instrument setup need to overlap with those from the previous one. It is the comparison of these overlapping points and the subsequent averaging of their positions which is the purpose of the Rail Overlap command. Here we see such a survey, and I've turned on in Configure DTM Display the Radiate option for dot display, and you will see that the same points have been surveyed from two separate setups, and it is the comparison of the positions of each of these matching pairs of points that is the purpose of the Report Rail Overlap command. There will very often only be a few millimeters difference in position between these points. Opening up the help documentation shows some very useful diagrams which explain the survey process. Here we have surveyed points along a rail taken from two separate setups, and there are usually a minimum of 3 overlapping points on the same rail at the same location but surveyed from two separate station positions. And if we zoom in on those overlapping points, we will see the points in red which are surveyed from setup number 1, the points in green are the surveyed points from setup number 2, and the blue points are the averaged, adjusted points through which an adjusted rail will be created. Some surveyors prefer to use point features for the overlapping points. So from setup number 1, the coding will be the code for the rail, and the first 3 points from setup number 2 will be coded with point features unique to this particular task. The help documentation explains the methodology behind how the meaning of the positions takes place, together with screenshots displaying the individual dialogues that the user will encounter. We now turn off the Radiate option, and we can see two pairs of rails, and these are the link features that we will be adjusting using the Rail Overlap command. We enter Report Rail Overlap, and we can choose where to send the report to, whether it be a printer, an Acrobat document, a file, or a comma-separated spreadsheet formatted file. And we will perform the adjustment for each rail in turn. But before we do so, I'd like to show you the importance of the section position file. The section position file is purely there as a guide to us in order that we can locate points which may fall out of specification. We select our first rail, in this case RD. If the surveyor has used point features for the overlaps, then we can select the feature code that is being used for that. In order to prevent the adjustment from finding points on the wrong rail or finding them from adjacent link features, then we set a maximum search distance. Whether the data is radials or coordinates, well, in this case all of our points are radials. And also we give it some indication of the minimum and maximum distance between the groups of overlapping points. The specification will often give that range, and as long as the min and max values are slightly beyond that range, then it will always find the overlapping groups of points. If the number of overlapping groupings is not 3, which is the standard, then we can define how many overlap groupings there are likely to be. And in terms of the pre-adjustment tolerance report that will be produced, we can ask the system to report where we have exceeded specific tolerances. This is that pre-adjustment tolerance report, and for each chainage it reports an offset from the section position file at that chainage, the observation number, and also what the tolerance report warning is. In this case, there are not enough groups of points within this overlap. If any of these messages need to be dealt with, then at this point we can go back, find the points and make relevant adjustments to them. Otherwise, if we select Next, it will now perform the amendment of the points, adjusting the mean positions of the overlapping points, and for each chainage, offset and coordinate it will tell us what the horizontal and vertical difference is between the groups of points for each individual setup. For example, this is setup number 86. The station was S12C, the backside station was S04B, and this set of points is overlapping with setup 82. The station was positioned at S04B and the backside station was S26B. Any points which exceed that tolerance value will be flagged in that report with an asterisk, and when we select OK, if we have exceeded those tolerances, then LSS will not be able to mean those overlap points. Which means that if we go back to rail overlap, we can change these values. We've rerun the report, this time with different tolerances, and it now gives us the option to continue with the meaning of the rail overlaps. We repeat this exercise for as many rails that we wish to adjust, and generally the requirement is to produce a single string for each rail in MX rail format, that's GenIO format, or in AutoCAD DXF format. And in order to make sure that each rail is strung from the start right the way through to the finish, then we recommend that you select Output, Survey, create a new survey name, by selection filter, select individual observations, and then the string of observation mode, and for each individual rail, making sure that the arrow is pointing in the correct direction, that is of increasing chainage. This will now generate a LSS survey with all of the points strung in the correct order from lowest to highest chainage.